Hi everyone, I'm going to look at types of data that we can get. First of all, the outcomes for this session. You have to know the definitions. Think of it like learning a new language. In order to understand the language, you need to know what the different words mean. Right, so that's why you'll see usually at the start of the list of outcomes that I have, I always say know the definitions. Then secondly, identify the 4 types of data in a data set. Now, this is really important to know what type of data you're working with, because in statistics we have different types of methods of analysis for different types of data. And not just analysis, but even just summarizing data. We have different methods that's suitable for the different types of data. Right, let's start with an example. Suppose that I have a population of cars and it's something that I wish to investigate. And from that population, I'm going to select a sample of size 12 cars. Now, the sampling is done without replacement because I don't wish to repeat the same vehicles in my sample. I want new information, so I'm sampling without replacement. Now, initially, in order to select a random sample of size 12, I had to label all the cars in my population. The number of cars is 96, so that'll be my capital N, and I will label them starting with 01 and ending with 96. Remember, to ease our simple random sampling process, we have to keep the same number of digits in our labels. Right, so here we have the labels of the vehicles that were selected in my sample. Now what I want to do is I want to list these cars and then hopefully list the properties of those cars. So what I'm going to do is I'm going to create the first column over here for a table, and it'll just be the vehicle number. Now take note, it's not the label of the vehicle that it had in the population, this is just the number, so that I can see how many vehicles I actually have. Right, so each one of the rows that I'm going to create in my table will represent a case or a sample point or an element or an observation, whatever you want to call it. Right, so each row will be a sample point because each row will represent one of these cars, and within that row we will have things describing those cars. In other words, we'll have the data for each car within each row. Right, so I'll start off now by putting the cars in no specific order in the table. Okay, so I've moved it from my diagram to my table. Now please note that, very importantly, this is just the list of cars. It is not the actual data because we haven't said anything about the cars yet. We haven't started describing the cars. So we don't have any information about the cars. So no data yet. The way in which we will go about doing it is by adding different descriptors for each of the cars. And the first one that I'm going to add will be the color of the car. So obviously we'll have red and yellow and blue and green and gray going down the list. So now I actually have a data set because I've listed something that describes the observations. Right? I'm listing the colors that describe the cars. So now I have information. In other words, I have data. Now note, the data is in no specific order. Now if the data hasn't been processed yet, in other words, no specific order, it's just like we observed it or like we selected it, then we call it raw data. If on the other hand, we start organizing the data or arranging it, then we'll call it group data. So if I were to take the cars and create a table, and then the table summarizes the colors, then I'll group together the cars that are the same color, and I might be interested to know how many of each color I have. So I see that I have 2 red, 2 yellow, 4 blue, 3 green, and 1 gray. So by arranging it or summarizing or grouping it in this way, it makes it easier for me to extract certain information from the data set. But for our purposes, for this example, we're just going to have a look at the raw data. In other words, as I selected it from our population that I had here to my sample, I just made the list with no specific order in mind. Now, the first variable that I've listed here is color. And the variable is the name that we use in statistics for a characteristic. In other words, something that describes an element. That characteristic, we'll always call it a variable. That is the thing of interest. And a variable, like the name says, the value varies. It changes. So we see here we have a variable color. That's the name of the variable, but the value of the variable will change. Red, yellow, blue, etc. Now, in this case, we only have one variable that describes our observations. So we'll say that we have univariate data. Uni meaning one, right? Univariate data because there's only one thing describing the cars. That thing that's describing the cars is color. Now, color is a category. It's not an actual measurement like we would normally think of measurement, where it will be a weight or a height or a distance or something like that. Right, this is a category. And if we have a variable that is not a measurement, then we call it a qualitative variable. So in other words, we are describing a quality about it. It is like a label. Now, color has no natural order. In other words, there's no natural way really of organizing or sorting colors. Usually people will list colors according to their preference. So because there's no natural order, we'll simply say that it is a categorical variable. So it's qualitative because it describes a quality, it's not a measurement, and it's categorical because there's no natural order. There's simply the different categories. Now, if I add another variable, let's say age, then I have two variables now in my data set. So I'll call it bivariate data. Now the age over here will be the age in years for the vehicle. So I've measured something about the vehicle now. I've measured the age. Because it's a measurement, it's a quantity, and I call it a quantitative variable. It's not a label, it's an actual measurement. Right, it's a numerical value, so we'll call it a quantitative variable for quantity. Age in years, these are whole numbers or integers, so I'll call it a discrete variable. So it is quantitative because it measures something, and it's discrete because I'm counting something. The age is the number of years that I count for the vehicle. Right, if we add another variable, let's say distance traveled. So if you look at the odometer of the vehicle, you'll see the kilometers that's on there. And now I have three things describing my vehicle. So I will simply say that I now have multivariate data. Usually if we have one variable, we'll say univariate, two will be bivariate, and anything more than that, we just usually say multivariate data, because there's multiple things that describe each of these observations, right? Each of these cars. Now, distance is also a measurement because we're measuring how far the vehicle has traveled. So, again, it'll be a quantitative variable. Quantity, which is measurement, it's numerical. But this is slightly different to the previous one that we had. The age was age in years, and we counted the age. This is a measurement, and it has decimals, so it's not something that we're busy counting. You can think of this really more like a measurement, like temperature or weight and distance. So because it has decimals, we'll call it a continuous variable, because by changing the decimals, we can really make the distance any value in an interval. It's not just the whole number, an integer. Now, if we add another one, let's say risk. Now, let's say this is the risk of the vehicle being stolen. Now we have four variables, so you should have guessed we still have multivariate data. Now, risk is not a numerical measurement, it is a label. Although it is based on certain factors that can be measured, the risk itself is just a label that we attach to the vehicle, right, to the observation. And because it's not a measurement, but it still is a variable, we'll call it a qualitative variable. So, like color, it is qualitative because it is a label. However, there's a difference. Where color has no natural order, risk has a natural order. If we look at the risk associated with each vehicle, we see the first one is a high risk, second one is a medium risk, another high risk, there's a low risk. Now if we think of these risk levels, if somebody were to ask you to write down the risk levels, then it'll just be a normal reaction to write down high, medium, low, or low, medium, high. But we tend to think of it in one of those two orders. So because there is sort of a natural order to this, we call it an ordinal variable. Okay, because there's an order to it. Now, if we go back and we have a look at the original list, then you'll see that I've just got the cars listed over here, but the actual pictures of the cars. Whereas in the sample, I had the labels that I gave the cars in order to select them from the population. Remember, the population capital was a capital N, the population size, and there were 96. So these were the labels of the cars that were selected. So in my table here, where I've now listed all the data that I have, I'm not going to have pictures of cars, but I still want to know which cars I'm working with. So what I'm going to do is I'm going to replace each car by its label. So the little red one over here was 0.4, and the next one, the yellow one, is 54. So if I do that for each one, then I have my proper data table where I have my observations, and these observations are identified through the label that I gave them in the population. And for each of these cases, remember earlier definition, one row is a case. So for each of these cases, I have 4 things describing each of the vehicles or each of the cases. In this case, color, age, distance, and risk. Now, for my example, I collected new data. In other words, I went out into the field and I identified the cars, I selected the cars, and I wrote down the variables from what I saw. So because I collected the data myself, I'll refer to it as primary data. On the other hand, if it was data that was already published somewhere, maybe in a newspaper article or in a magazine article that had a list of cars and the specifications describing the cars, because somebody else collected it and published it, but I'm using it, for me it will be secondary data. Right, so primary data and secondary data are the two sources that we have. Now, notation is something which is really, really important. You see here I wrote it in red, notation. Usually we won't write out everything like it is over here. We will abbreviate things. Now, color, age, distance, and risk are the names of the 4 variables. Okay, because it's names, I will write them down as capital letters. Now, usually what I do is I will take the first letter of the variable name. So in this case, color, capital C, and I'll just write down capital C. Age will be a capital A, sorry. Distance will be capital D, and risk will be capital R. Now, variable names are always single capital letters, and usually, but not always, like in my case, but usually it's the last letters of the alphabet, X, Y, and Z. So you're going to see this a lot. Capital X or capital Y or capital Z. So when you see that, you must associate it with all possible values that that variable can take, because it's a name. It tells us the name of the variable and it refers to all possible values. Now when it comes to the actual values, we replace the values with lowercase letters. So color is a capital C, but the color for the first car will be lowercase c subscript 01. So the lowercase c tells me this is now a specific color. And if you can recall from what I had before, it was red. Okay, so that's a specific color. So it's a lowercase c, and the subscript will be 01 because it is the first one in my list. The same with age. It's the first vehicle in the list, so the subscript or the index will be 01, and because it's a specific age that I'm referring to, it will be lowercase a. The same with distance, lowercase, because it's a specific distance for a specific car, 01, and the same for risk. So I'll do that for each one, and this is what we have. So generally we will have capital letters at the top of the columns, because that refers to the variable name, and then we'll have lowercase letters with an index or a subscript referring to a specific value for a specific case. So in summary, our data table will look like this. Capitals, lowercases with indices, and here we will have the sample size, tells us how many cases we have. And in here, and to get here as well, just as important, we will sample either with or without replacement. We will have either raw or group data. We can arrange the data over here in a specific way, which will then turn it into group data. Primary or secondary data. Primary is the researcher themselves collecting it. Secondary is that they got it from somewhere else, from another publication. Univariate, we only have one variable or characteristic describing elements. Bivariate, we have two, so just x and y maybe. Multivariate, we have three or more. The variables, the names are always single capitals. The actual values will be lower cases with an index. The two main types of variables, qualitative, which is a label, it's not a measurement. It can be either one that has a natural order, like risk, high, medium, low, or it can be like color, which is categorical, there's no natural order. And the other variable is quantitative, it's a measurement, and it's usually either discrete or continuous. Discrete meaning it's something that's counted, continuous meaning it is something that is measured, like temperature or distance or weight or height, usually something with a decimal. Right, now as I said in the beginning, the section on data is extremely important because the way in which the data will be summarized, right, the methods used to summarize data and to analyze the data will be determined by the type of data that you have. So you must be able to identify the type of data.